In this example, you're asked to solve the equation tangent of theta over 2 is equal to 3 minus 2 tangent of theta over 2, where theta is between 0 and 2 pi radians. So the first thing to do, as always, is, well, with these linear trigonometric equations, is to isolate the trig function. So we'd like to isolate tangent. This equation only involves tangent to the first power. So let me rewrite the equation below here while I have a little more room. So tangent theta over 2 and so the first thing I would do to isolate tangent is to first collect them on one side. So I would add 2, and you could subtract tangent of theta over 2 from both sides as well, but it's nice to, whatever quantity you're solving for, it's nice to make it positive. So I'm going to add 2 tangent of theta over 2 to both sides, and that will give me 3 tangent of theta over 2 is equal to 3, since this is gone now over here. And so the last thing to do to isolate that tangent function is to divide both sides by 3. So you have tangent of theta over 2 equals 1. And so you may have seen that in the last several examples. The first task is to get the trig function by itself. And now we've done that. Once you have the trig function by itself, then you grab a unit circle and have that on the next. So we left off with this step. Tangent of theta over 2 equals 1. Now remember, 1, sorry. Now remember that tangent's equal to sine over cosine, which on the unit circle, that's y over x. Sine is given by the y-coordinate for each of these points on the unit circle, and cosine is given by the x-coordinate. So here's your sine over cosine. And we want that ratio to equal 1. So y over x is equal to 1 when x and y are the same. I mean, here y over x would be 0 over 1, that's 0. Here it's 1/2 over the square root of 3 over 2, which, by the way, those halves will cancel, and so this ratio y over x is equal to 1 over the square root of 3. Here, they're the same. So let me circle that. So tangent of pi over 4 would be equal to 1. The ratio y over x would be equal to 1. Over here, y over x would be negative 1. But down here, at 5 pi over 4, that ratio would also be 1. So we do have a solution here as well. And then in quadrant 4, x is positive, y is negative, so the ratio will come out negative. We don't want that. Right now we have tangent is equal to positive 1, so that's what we're looking for. Okay, so we haven't addressed the theta over 2, I know. But so what I've said in the last few example videos, if you have anything more than just plain old theta, then we should start by describing all solutions. So let's see what I have here. I have theta over 2 equals, let me go with the pi over 4, that first solution that we found, plus, now the period for tangent is pi, so I could write plus pi n, or I could write plus 2 pi n if I'm not really thinking about the period for tangent. But let me tell you that will save you some time. So you'll end up with the right answer in the end either way. If you're thinking, well, I would just do plus 2 pi n, and then I would go down here and write 5 pi over 4 plus 2 pi n. You'll get the same solution set. But let me, it's going to be a little quicker if we do it this way. So if we recognize, okay, this is the tangent function. The period for tangent is pi. We wrote 2 pi n when we were solving with sine and cosine. So pi n is saying I just have to go through pi radians, and then I'm back in the same position for a cycle of tangent. Okay, notice that if we add, for n equals 0, we get just theta over 2 equals pi over 4, and that's this that corresponds to this solution over here. If we add a whole pi, that would be 4 pi over 4. Add 1 pi over 4, that gives you 5 pi over 4. So you're going to get this solution when n equals 1. And then if you add pi again, you're going to be in this position, add pi again. Remember that pi is halfway around the circle. So we're going to keep, you add pi, you're here, add pi again, you're here, add pi again, you're here. So just adding pi in is the most efficient way of describing this solution set. Okay, enough about that. So we need to isolate theta now. So I'm going to multiply by 2 on both sides. So I'm going to just multiply each part of this by 2. So 2 times theta over 2 equals 2 times pi over 4 plus, that's a 4, 2 times pi n. Okay, so the 2's cancel here. And again, the reason I've added on this plus pi n is because to play it safe, anytime you have more than, if you're solving for more than just theta here, it's best to write all solutions, or that's the method that I'm using in my video explanations. Okay, so 2 times pi over 4, so I could cancel a 2 here, and that'll leave a 2 in the denominator, right? If I divide top and bottom by 2, I'm left with pi over, oops, not 4, I'm sorry, I keep doing that. Need more sleep. Okay, pi over 2. Yeah, divide top and bottom by 2. Plus 2 pi n. Alright, and this will generate all solutions. Now the problem asked us to find the solutions between 0 and 2 pi radians. So we want to list just the solutions that fit in that interval. If n equals 0, if you don't add anything, I guess I'll write this down. If n equals 0, then theta equals pi over 2 plus 2 pi times 0, which that's just pi over 2. And that's certainly in the interval between 0 and 2 pi, so we'll list that as a solution. Now notice, if we let n equal 1, and I'm sorry, I'm going to write on the unit circle again, n equals 1, then theta equals, I'm just using this formula right here. So then n equals pi over 2 plus 2 pi times 1. But notice that's definitely bigger than 2 pi, because you're taking 2 pi and you're adding something positive to it. So that's going to be too big. You're going to blow past 2 pi. If you do pi over 2 plus 2 pi, you're out here. 2 pi plus pi over 2 is outside of that interval. So already with n equals 1, we've gone too far, so that's the end of your solution set, just pi over 2.